Well, welcome back, folks. J Lamb Bio here to talk to you today a little bit about phase changes. That's right, we're going to take a look specifically at what happens on a molecular level as well as an energetics level on what happens when chemicals undergo changes in their states of matter. So we're going to look at solid to liquid, liquid to gas, and quite a few other different phase changes and what happens specifically to those chemicals on a molecular level. So the goals today, you should be able to explain the different phase changes that occur between different states of matter, as well as evaluate a phase diagram and phase change graph. We've got some key vocabulary terms here for you. We're going to talk about melting, sublimation, freezing, vaporization, condensation, deposition, phase diagram, triple point, and critical point. So keep in mind, and I'm sure you're all very aware of this, that solids, liquids, and gases can change into different states of matter based on the pressure that's applied as well as the temperature of the material. You know about melting and freezing, condensation and vaporization, and all of those are directly related to the energy that is in the system as well as the pressure that is applied in the system as well. We will look at a diagram that shows what state of matter a chemical is at a specific pressure or temperature. So what are the ones that you need to make sure that you know? Well, melting is from solid to liquid. Sublimation is solid to gas. We'll actually look at that in class. That's your key word for the day as well, is sublimation. So feel free to put that into the blank that is provided. We'll talk about freezing, which is liquid to solid. I feel like I'm talking to a bunch of third graders right now. Vaporization, which is liquid to gas. Keep in mind that's not boiling. Boiling is only really associated with water. So we'll focus on vaporization. Condensation, gas to liquid. And deposition is going from a gas directly into a solid. So keep in mind that energies change when phase changes occur. And energy in a system is directly related to temperature. So obviously when I increase the temperature, when I add heat to the system, I'm going to change states of matter. At the very lowest temperature, you can see we have a solid. So the far bottom left-hand part of that chart, we have a solid. As we increase the amount of heat that is added to the system, we increase the kinetic energy of the molecules, thus increasing the temperature, which you can see the temperature goes up. At 0 degrees, which is the freezing point of water, energy is added, so it's kind of in that liquid solid state. So it's kind of somewhere not all solid, not all liquid. It's somewhere kind of in between, and we need to continue to add heat to make that entirely a liquid. We add more heat, that increases the kinetic energy, increases the temperature until we get to 100 degrees, which is the boiling point. We have a gas liquid, and then we continue to add the heat. The temperature doesn't increase, but that liquid becomes a gas. So what this implies in those areas that have liquid, solid, and gas liquid is that energy is required to make the phase change. It will not change the temperature, if you notice that. The graph doesn't change, but it does change the state of matter. It goes from a solid to a liquid or liquid to a gas. So kind of keep that in mind, that there is energy required to change the state of matter from a solid to a liquid or a liquid to a gas. Now this is known as a phase diagram, and phase diagrams show different states of matter at different temperatures or pressures. So if I were to give you a certain temperature and a certain pressure, you treat it like a graph and you follow the coordinates, and that actually tells you what state of matter it's in. So you can kind of see here to the left of the green line here, you have a solid state of matter. So anything that is above the red line and to the left of the green line is solid. Anything to the right of the green line and above the blue line is a liquid, and anything to the right or below of the red line and blue line is a gas. So the lines represent phase changes between different states of matter. So if I cross the red line, going from left to right, I go from a solid to a gas, which would be sublimation. Or if I go from a gas to a solid, that is deposition. Notice if I go across the blue line from liquid to gas, that is vaporization, or if I go gas to liquid, that is condensation. Now there are two other points on this graph. There's a triple point where all three states of matter can coexist at the same time, which is pretty cool. That there's solid, liquid, and gas all at the same time at the specific pressure and temperature. And then a critical point is the highest pressure and temperature that a liquid can exist. So at some point in time, you actually get to too high of a pressure, too high of a temperature that a liquid phase cannot possibly exist. And then that just becomes gas any place to the right of that critical point. So we'll take a look and we'll analyze some of these graphs in a later video or in class. But keep in mind that phase changes are common and require a change in the energy of the chemicals, and that phase diagrams help us understand what state of matter can exist at different temperatures and pressure. Pretty straightforward video, guys. Hopefully you guys understand the differences in the phase changes and a little bit about the diagrams that you're going to be looking at in class. This is JLand Bio. Have a great day, guys. We'll talk to you later. Bye-bye.